Hey guys, in this video we would understand how to represent vectors on x and y axes. Representing vectors on x and y axes also means writing vectors in component form. Before starting how to represent vectors in x and y axes, let's first understand how to draw a given vector. If you're given a vector OA in its magnitude and direction form, and let's say the magnitude is 3 centimeters. Direction we are given is north 28 degrees east. Now how do we read this direction? This means the vector is drawn 28 degrees east of north. So if we turn this vector into a diagrammatical form, we go in between north and east axes. So north is here, east is here. We draw this vector in between north and east axes, and along with the north we join angle 28 degrees. So between the vector and the north direction is where we make this angle 28 degrees. So whatever direction is first, that is where we would join the angle. How do we read this? This is 28 degrees east of north, and this vector is OA. Magnitude of this vector is 3 centimeters. There is another way vectors can be drawn, and in that case you'll be given bearing for directions. Now what do you mean by bearing? So for example, if we're given vector OA, let's say 5 centimeters, and we are given with a bearing of 60 degrees. Now the word bearing always means the same thing. It means we start at north and turn around in clockwise direction to span 60-degree angle. So what does this mean? If we have to make a vector OA, we make the coordinate grid. This is north, this is clockwise direction. We span 60 degrees angle, and wherever we reach, let's say we reach here, this is where we form the vector. If this is 5 centimeter, we mark 5 centimeter. So this is OA, and again using bearing we are able to draw the vector when the angle of bearing is known. One more thing here to remember is that if let's say we have a vector between this north and west direction, and this angle is let's say 48 degrees, let's call this vector OB. How do we write this down? We can write this down as vector OB, and we are given this magnitude as 2 centimeters. So we write down vector OB is 2 centimeters. Direction that we are given is along with west, so we put west first. 48 degrees in between west and north. So we put west here and north here. How do we read this? This means 48 degrees north of west. So once we've drawn this, we can also write this vector in another way. We can say vector OB is 2 centimeter. Magnitude is still the same, but the direction now, instead of taking from west, we can take it from north, because we know this total angle is 90 degrees. So if this is 48 degrees, this would be 42 degrees. So we can write down with north 42 degrees in between north and west. So this or this means the same thing, because we have the same magnitude. Directions, no matter which way we are taking from, we are taking from west or we are taking from north, numbers are complementary. So you add these numbers, you get a 90-degree angle. So these are two different ways we can represent a vector when given in a cardinal axis. Now let's understand how to represent vectors on x and y axes, or how to do the component method. Let's take up the same example. Component means how much part of this vector lies on its respective x and y axes. So here the respective x-axis is the negative x-axis, which is west, and respective y-axis is the positive y-axis, which represents north. This vector lies in between west and north. That means it has some component of it that lies on north, and it has some component of it that lies on west. Now how much component of vector OB lies on the y-axis or on the north axis, and how much component of vector OB lies on the x-axis or on the west axis is called component form of vectors, or representing vectors on x and y axes. So what are we going to do is, now we're given this angle 48 degrees, we'll make the angle, and whatever side the angle is given, we join the vector to that axis. So since we're given the angle with the x-axis, we'll join this vector with the x-axis, and this is given to us as 2 centimeters. This is our y value. This is going to be our x value of this vector. Now finding how much of this vector lies on the x-axis means we are finding the x component of the vector. Now we would see that this x component is nothing but an adjacent of angle 48 degrees. And we're given the hypotenuse because this is a right angle triangle. We can use trigonometric ratios in there. So we can say cos 48 degrees is equal to adjacent, which is x, over hypotenuse, which is 2. So x value of this vector would be 2 times cos 48 degrees. And the answer is 1.34. So 1.34 centimeters of this vector part lies on the x-axis. Now to find out the y component, we know for this angle y is opposite and sine ratio is opposite over hypotenuse. So we would do sine 48 is equal to y over hypotenuse, that is 2. And this would give us 2 times sine 48 degrees. And that's equal to 1.49 centimeters. So this is how we split this vector into its component forms. Now there is a shortcut to find these components. So what all do you have to do is, if you're given a vector, let's say here, this is south, this is east, south is negative y, east is positive x. This vector is given to us as, let's say, 5 centimeter. We're given this angle to be 34 degrees. So always remember, when we are finding components, we always multiply the cosine of the angle with the magnitude of vector to get the component on which the angle is lying. So in this case, the angle is lying on the y-axis. So y component will be cosine 34 times 5. And the other component, that is your x component, would be sine 34 times 5. So whatever side the angle is joined, that side is always cosine of the angle times the magnitude. Similarly, if we have angle joint to the x-axis, let's say this is 28 degrees and this is the vector magnitude is 2 centimeters. Now we see the angle is joined to the x-axis, so x component will be equal to cos 28 times the magnitude, which is 2. Y component will be sine 28 times the magnitude. And then you can put this on the calculator and see what's the value.